Okay guys, this is where we start putting skills together. We've already learned how to do the pre-AP, or we've reminded ourselves on the pre-AP skills that we need to know, and so we start putting skills together. Here's our first thing we're going to do for AP Chemistry. It's called net ionic equations. We're going to be taking notes together, so make sure that you take notes with me as we go along. And we're going to take skills we know, we're going to move forward. I'm going to take an equation. A very simple double replacement reaction. Lithium chloride, sodium bromide produces lithium bromide and sodium chloride. Plus 1, minus 1, plus 1, minus 1, plus 1, minus 1, plus 1, minus 1. So I'm checking the charges. We've got one lithium on this side, one lithium on this side, balancing. One chlorine, one sodium, one bromine. Okay. Most of these equations you're going to see AQ. AQ, aqueous, 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 aqueous. Reminder, aqueous means that the substance dissolves into water. It's in a solution of water. So when I dump salt into water, I can have, if I see NaCl that's a solid, that means salt like coming out of the salt shaker. But if I see NaCl with an AQ, that means it's dissolved in water. So the first thing I want to say is, all of this is dissolved in water, but you don't see the water. And the reason you don't see the water is water's on both sides, so we just ignore it. Okay? Now, taking what we've known from the past, we know that when we drop salt into water, it does this. It dissociates. It breaks up into ions. When it breaks into ions, these are what are going to be floating in the water. So when it says AQ, here's what's really happening. These ions are floating in water. Okay, so if you had a container and you drop salt in the water, then you're going to have these sodium and chlorines floating all in the water. Okay, you're not going to have really any salt on the bottom. That's why when you go to the beach, you don't see salt. You don't get a snorkel and see salt on the bottom. If you saw salt on the bottom, that would be a precipitate. And a precipitate is when something forms a solid. We'll deal with that here in a minute. But it's all ion form. Okay? Now, what we want to do is we want to take this equation and look at what's going on. So the first thing we're going to do is we're going to do what is called the total ionic equation, which means you're going to break everything up. Since this is aqueous, that means that first compound does this, AQ, plus Cl minus 1, AQ. This is where you practice your charges. Okay? Second one dissociates. It's ionic. How do I know something's ionic? It's on the left and the right of the stairs on the chart. So the left side of the stairs and the right side of the stairs. Okay? And this is going to produce, so I'm going to have the sodium, AQ. This is a lot of writing, and I know that. You just have to write all this down. Okay, so all of this is really what's happening when we write this and this. Now this is different from first year chemistry, because first year chemistry we don't take this step because we're not going to the level of AP Chem. So after the arrow, now I don't have room, so I'm going to write it here. I get lithium plus 1, aqueous, plus bromine minus 1, aqueous. And I'm going to have sodiums plus 1, aqueous, and chlorines minus 1, aqueous. Again, I know this is a lot of writing, but here is everything that's really happening on the left of the equation, and here's what's happening here. So everything's broken into ions. Okay? That's not really hard to do. Now I'm going to do something with it here in a second. So I'm going to move this whiteboard. I'm going to come back to it. I'm going to grab my other whiteboard. Actually, I'm going to grab a piece of paper to show you how this other one works. Okay? So let's take one that's a little bit more complex. Okay? So let's take one like this. We're going to take NH4 ammonium iodide plus calcium bromide to produce ammonium bromide and calcium iodide. All right, so plus 1 minus 1, that's the correct formula. Plus 2 minus 1, whoops, I left the 2 off. Okay, so you got to be careful. Plus 1 minus 1, so it's just a double replacement. Plus 1 minus 1, plus 2 minus 1, so the numbers are correct. Now the difference between this one and the first one is everything in the first one was plus 1 minus 1 all the way across. This one's not. Okay? Plus 1, minus 1, plus 2, minus 1, so I need to switch and get the 2. Plus 1, minus 1, plus 2, minus 1, so I needed the 2. This is all based on writing compounds, and you've already done those videos. So when I want to write the total ionic, here's what I'm going to do. Is I'm going to turn it sideways so it all fits a little bit better. Oh, but I have a problem. What happens when you have a reaction like this? It's not balanced, is it? I see 2 bromines and only 1 bromine, so I need a 2 there. This is a skill from first year chemistry. 2 ammoniums mean I need a 2 there. 2 iodines, they match. Looks like I'm done. Check my work. 2 ammoniums, that matches. 2 iodines, that matches. 1 calcium, got it. 2 bromines. All of these are aqueous. Everything's aqueous. And so, my total ionic, I'm going to put it where we can see all of it on the screen. Looks like this. First compound, NH4 plus 1. Now, if I look at the formula, how many NH4s are there really there? There's 2 of them. So I'm going to have 2 NH4s floating around when everything breaks up. I'm also going to have 2 iodines. So the 2 ammonium and the 2 iodine. What's the next compound? How many calciums are there? There's only 1. But notice the charge is a plus 2. Here I have 2 bromines. So I'm going to have bromine minus 1, and there's 2 of them. AQ, and then my arrow. I'm writing big enough so you can see on the screen, so it takes up my paper a lot. Okay? So I have 2 ammoniums, 2 iodines. 2 ammoniums, 2 iodines. So I have to account for every ion that's floating in the container. 1 calcium and 2 bromines. 1 calcium, 2 bromines. Notice I did not write it as Br2. You may think, but Mr. Kelly, I learned in first year chemistry that that's a diatomic. Whenever it's by itself, it's in pairs. You're right. But that's when it's in gaseous form. Okay? When it's in the element form as a gas, it's found in pairs, but this is in solution. So it breaks into ions. Everything's breaking into ions. There's my arrow. What's the other side look like? Well, I have a big 2 there, so there's 2 ammoniums, 2 NH4 plus 1s, aqueous. I also have 2 bromines. And then the last compound, I have 1 calcium, AQ, and 2 iodines. Now here's your first aha moment. Notice the law of conservation of mass works. And what I mean by that is we started the law of conservation of mass by just balancing it. But also notice my ions balance. I have 2 ammoniums on the left. I have 2 ammoniums on the right. I have 2 iodines on the left. I have 2 iodines on the right. I had 1 calcium on the left. I had 1 calcium on the right. 2 bromines and 2 bromines. So the law of conservation of mass has to stay the same. Okay? Whether it's an ion or atoms when you're balancing. Okay? Here's one for you to try real quick. Aluminum chloride, AlCl3 plus MgBr2 yields AlBr3. Wow, where are those changes? Plus 3, minus 1, switched. Plus 2, minus 1, switched. I'm just good at it because I do it all the time. Plus 3 on the chart, minus 1, needs a 3. Magnesium and chlorine, plus 2, minus 1, so I switch. There's your formula. Is it balanced? Probably not. Balance it, and then come up with the total ionic equation that matches it. So pause the video, get that done. We'll come back here in just a second. All right, let's see how we did. You had AlCl3. I have to move to another sheet of paper. That one was run out on, so AlBr, transfer it real quick, plus MgCl2. Balancing the equation, 1 aluminum, 1 aluminum. 3 chlorines, 2 chlorines. They both go into 6, which means I need a 3 there. It also means I need a 2 there, which now gives me 2 aluminums. 2 aluminums and 6 bromines, which means I need a 3 there. Did you get that balancing? 2 aluminums, 6 chlorines, 6 chlorines, 3 magnesium, 3 magnesium, 6 bromines, 6 bromines. Okay, total ionic. It's going to be long because I'm writing it big, but what do we have? All of these are ionic, and they're all aqueous. So, how many aluminums do I have? I have 2 aluminum with a +3 charge, aqueous. This makes you practice your charges off the chart, as well as using your coefficients. How many total chlorines? 2 times 3 is 6 chlorine ions. In this compound, I have 3 magnesium plus 2, and those are aqueous. I'm going to have 6 bromine minus 1, aqueous. That's the whole left side of the reaction. The other side, 2 aluminums. Now I know there's somebody already thinking, but Mr. Kelly, can I just copy what I have from the other side? Oh, we're going to hit some issues in a minute, so make sure you use what you have. 6 bromines, 3 magnesium. Working on my charges, make sure you're getting your charges right, and 6 chlorines. Pause the video, make sure you have exactly that. Make sure you have exactly that. One more for you before we use it for something here for a minute. NH4Cl is going to react with AgNO3. So I used a polyatomic. Okay, so we'll talk about that here in a second. Everybody's aqueous. So notice NH4 is still NH4, that's ammonium. So +1 minus 1, +1 minus 1, +1 minus 1, +1 minus 1. So that's balance. I don't have to put any big numbers in there. So go ahead and write out the net, pause the video, write out the net ionic. Okay, when you wrote that one out, you should have 1 NH4 plus ion plus 1 Cl minus ion. You write that real quick. So you're going to have 1 NH4 plus 1 aqueous. Make sure you write the aqueous every time. 1 chlorine aqueous. You're going to have 1 silver aqueous. You're going to have 1 NO3 minus 1 aqueous. You're going to then have Ag plus 1 aqueous, Cl minus 1 aqueous. Ooh, I'm running out of space. NH4 plus 1 aqueous. Cram it in there. NO3 minus 1 aqueous. It's a pretty easy skill. It's not very hard at all. Okay? So you should have this real quick. You're going to practice some of these net ionics. It's not too bad. But what I want to do is I'm going to erase these examples. I'm going to come back to those in a minute. Is I want to take that equation and I want to show you where we start using this. Okay, so I'm going to take the one that you just had and I'm going to go ahead and write the total ionic for it. Okay, and so it was NH4 plus 1 aqueous, and I just couldn't fit this on the paper, that's why I'm redoing it real quick. Aqueous plus Ag plus 1 aqueous. Now you're going to make a change in your notes here in a second, so watch carefully. Aqueous, arrow, and then you're going to have something plus, and I'm going to explain what that something is in a second, so you're not doing anything yet, you're just following me. Now, your net ionic, I'm going to go ahead and do it like this. It's easier for me to do it than it is for you, so let me go ahead and do it like this, plus Cl minus Aq. Now, the other day, in one of the videos, you got one of these, which is the activity series on figuring out whether a single replacement reaction happens or not. Okay? It also has this in the middle, your solubility rules. Now this is a huge skill in AP Chemistry, so let me walk through it real quick. Basically what they want to know, and this tool is easier than some of the others I've seen. Basically, it works like this. Will substances dissolve into water? I call this the yes box and the no box, okay? Because you'll see it says soluble, and I'm going to send you a copy of this so you can print it and write on it yourself. These are all soluble in water, which means acetates are all, anything that's something acetate all dissolve in water. All ammoniums dissolve in water, nitrates, cyanides, hypochlorite, chlorite, perchlorite, bromides, chlorides, iodides, sulfates. All of these things dissolve in water. All of these things do not. So carbonate and phosphate and chromate and dichromate, hydroxide and sulfide compounds, those do not dissolve in water. So when you drop these in water, what's going to happen is, if you drop a carbonate compound, it's not going to do this. It's not going to do that at all. It's all going to just fall to the bottom and sit there. It doesn't matter how much you shake it up. It doesn't matter how much you stir it. That's insoluble in water. And so that's what all of those compounds will do. And so looking at this real quick, they had to add exceptions because there's always exceptions to the rule. So ammonium and nitrate and cyanide and hypochlorite, perchlorate and all that all dissolve in water. All bromides dissolve into water except for the heavy metal bromides. Silver bromide, lead bromide, and mercury bromide. Those are 3 heavy metals. You'll notice those are sort of the exceptions for all of them. If you have heavy metal bromides, they do not dissolve in water. So if you had sodium bromide, when you drop it in water, it's aqueous. Okay? If you had silver bromide, well, look at the rule. Bromide, silver bromide's an exception. It forms a solid, which means that's a precipitate. So if you make one of these, it's like it being in the no box. Okay, so I'll let that sink in for a second. So if I had silver chloride, look at chloride. All chlorides dissolve in water except for silver chloride, lead chloride, and mercury chloride. Well, silver chloride would be a solid, so it'd fall to the bottom. But if I had another example, such as instead of silver chloride, if I had lithium chloride, all chlorides dissolve in water. Is this one of those 3 exceptions? No. So this one is aqueous, which means it'll form ions and float around inside. Okay? So that's how the top box works. All the bottom box works like this. All of these do not dissolve in water except for these. Now, look up here. It says all ammoniums, no exceptions. All ammoniums dissolve in water. Well, look at this one. Carbonate. All carbonates do not dissolve in water except ammonium carbonate. Why? Because it fits that rule. All ammoniums dissolve in water. So if you have ammonium carbonate or alkali metals, woo, test your memory. Alkali metals are where? Column number 1 on the chart. Lithium, sodium, potassium, rubidium, cesium. Okay? So if I had sodium carbonate, which is that formula, carbonate does not dissolve into water. Is that ammonium carbonate? Nope. Alkali metal, sodium's in the first column, so this one is aqueous. But if it was calcium carbonate, all right, follow the rule. Carbonate's a no. All carbonates, is this an exception? Carbonate, calcium is in the second column. That's not an alkali metal, so this is a solid. Okay? So these are all the yeses, these are all the nos. There are a few exceptions, so you can use this to help you. Now you may think, why am I showing you that? Watch this. I had ammonium chloride to start this whole question. Ammonium chloride. Follow the rules. All ammoniums, do they dissolve in water? Yes. So they are aqueous. Matter of fact, it says all ammonium compounds dissolve. That's why ammonium is fine on the other side. Okay? I also didn't have just ammonium chloride, I had silver nitrate. Okay, that was the another that I started with, silver nitrate. So let's look at nitrate. There it is. All nitrates dissolve in water. Are there any exceptions? So silver nitrate is aqueous. So I broke it into its parts. Great. So I got this and this. Look what I made on the other side. I made AgCl, that was in the original formula, and NH4NO3. So let's look at this one. Ammonium nitrate. Ammonium, all dissolve. Nitrates, all dissolve. So this is aqueous. That's right. Yeah. But look at this one. Silver chloride. All chlorides dissolve except for silver chloride, lead chloride, and mercury chloride. I have silver chloride. So this is not aqueous. It's actually a solid. So here's what happens. Fix your work in your notes. What actually happens is, and you can just take what you just had, put a line through it, and write under it AgCl solid. By the solubility rules, something happened. I took these ions, and when I mixed them together, all of a sudden, I made a solid. By these rules, okay, I made a solid, and so fixing the equation, AgCl was a solid. So the total net ionic, correct. Now you wouldn't have known this till I just showed you. Okay. I'm sorry I pushed that off the screen a little bit. I apologize. Ammonium, this ammonium chloride is aqueous. Yep. Aqueous. But when they switch partners, this makes a solid. Okay. Now, that means you're going to use this resource to always check. Am I going to be solids or aqueuses on the other side? If it's an aqueous, you break them up. So you've already done that with 3 examples for me. Okay? Now, here's the last thing you have to know. From this total ionic, you get what we call a net ionic, which really means what's left. Okay? What's left? What's really happening is really what they're asking. Now, the first thing I need to teach you is what's called a spectator ion. Very simply, a spectator at a sport is somebody that does what? They just watch. And so they're just watching everything happen. So let's apply that idea up here. Who are the things that are watching? What do you mean? Well, I see NH4 on both sides and nothing changed. So they're just watching the reaction. Huh. I see ammonium, that is nitrate on both sides. Did chlorine change? Yes, it did. Did silver change? Yes, it did. So overall, here's the reaction that's going on. What's left? After I marked out my spectators, they were the same on both sides. They're just watching the reaction. That's all it means. So the reaction is really So in reality, what's really happening is silver ions and chlorine ions are making, this is the reaction that happens. Everybody else is spectators. Now, going back to what I said a while ago, there's somebody else that's a spectator we've never written down. Who was it? Do you remember? It's water. There's water all over this side and there's water all over this side. So we just take it as a spectator and we're just going to leave it out of the reactions instead of clouding up the reaction with waters that are on both sides. So we've already said that they're not counted, and so we have a spectator ion. Okay? So let's come back to the very first one that we ever wrote down, and it was this one. Okay? Let me get my red marker. Okay? So here was my total ionic. Let's see what you get. All right? Let's follow the rules. I had lithium chloride. All chlorides are yeses. They dissolve in water. Is lithium one of the exceptions? No. So it does this. That's great. I mean, it does this. That's great. Sodium bromide. All bromides dissolve in water except for the heavy metals. That's not one of the heavy metals, so that's right. What did I make on the other side? Lithium bromide. Bromides. All bromides dissolve. Is lithium? Nope, it's not one of the exceptions, so it breaks. It's aqueous. And sodium chloride. So I have chlorine is right there. All dissolve in water. It's not one of the exceptions. So it's aqueous, aqueous all the way through. So for my net ionic, what do I have? Spectator, gone. Just watching. Chlorine, spectator, gone. Sodium, that's supposed to be a plus sign. Spectator, gone. Bromine. So what does that really mean? Everybody's watching. There's no reaction. So if you poured lithium chloride with sodium bromide, all of this happens and it's just floating in the water. Nothing happens. They're all just floating around. When does something happen? Something happens when you make a precipitate, when you make a solid. So basically, when you make something that falls into this category, down here of the exceptions of insoluble, or one of these exceptions that's a no, then you have a reaction that happens. Okay? So here's what I want you to do. Go back to one of your other reactions that I had a while ago. I'll try to do them in order real quick for you. Okay? Let's look at this one. Okay? Follow the rules one more time and then you can apply it. Okay? Ammoniums are all yeses. Spectator. Okay? So it's going to do this. And iodide. All iodides dissolve except for the heavy metals. So they're aqueous. I shouldn't have marked out yet. Calcium and bromide. Bromide, all are dissolve into water, no exception. Broke it into parts. Ammonium bromide. There's bromide, no exceptions. It's not one of the heavy metals, aqueous, aqueous. Calcium iodide. Iodide, calcium's not one of the exceptions. So it's aqueous, aqueous everywhere. So NH4, two NH4s, spectator. Two iodines, spectator. A calcium, spectator. Two bromines, so this one was no reaction. Okay? Try it on this one, on your own. See if you can get it. Okay? So all you're doing is you're literally just writing out the total ionic, and then you're checking your solubility rules. If you make a solid, then you mark out your spectators and you show who's left. Okay? So sometimes what's going to happen, like in the case of this one, I got a solid right here. When I got a solid, all the spectators are all gone, and then what's left, net ionic, is what is left. What's really happening in the reaction is that right there. If all the ions disappear, like nothing forms into a solid like that one, then the answer is no reaction. So you're going to try it on your own. It takes a little practice. You have to write out all the parts. I'm going to give you some to do on your own. You'll do great. Practice them all. If you get stuck, let me know.